The greater the temperature of an object, the more intense the infrared radiation emitted from it will be. Remember that all objects will both emit and absorb infrared radiation. This causes them to release and take in heat to change their internal energy. Let's suppose we have two people. One is very cold because of their surroundings, and the other is very hot because they've been exercising. Both these people will be emitting infrared waves, but the cold person will only emit a few waves, while the hot person will be emitting a lot of waves. This stops the cold person from becoming too cold and helps the warm person bring their temperature back down to be closer to their surroundings. We can see this in things like ovens and heaters, which emit lots of infrared waves because of their high temperatures. But will the temperature of an object affect anything else about the waves it emits? Well, the temperature also affects which wavelengths of infrared radiation it will emit. Let's take a look at another example of a hot and a cold object. Here we have a cold can, which has just been in a fridge, and a hot cup of tea. Again, both of these objects will be emitting infrared waves, with the hot tea emitting more waves. The waves emitted by the cold can, though, will have a long wavelength, while the waves emitted by the hot tea will have a short wavelength. The hotter an object is, the shorter the wavelength of radiation it emits. Now, you don't need to know why this happens for your exam, but if you're interested in studying astronomy after GCSE, then you'll see how useful this is for analysing light from distant stars. So we know that temperature affects the wavelength of infrared waves. But what happens with even hotter objects, where the wavelengths get even shorter? Very high temperatures will cause the object to also emit wavelengths of visible light. So remember that in the electromagnetic spectrum, infrared waves are next to visible light. So waves with wavelengths just shorter than infrared will be visible. We can demonstrate high temperatures producing visible light with a metal poker. Metal is a great conductor of heat, so its temperature can rise to very high values if held in a fire. Initially, when the poker is at a room temperature of around 20 degrees Celsius, we don't see any sort of glow from the poker. This is because of the waves being emitted. They'll only have wavelengths for infrared radiation. Since we cannot see these waves, we don't notice them being emitted by the poker. Then when the temperature of the poker is raised to 500 degrees, we notice this orange glow at the end of the poker. The waves being emitted now have longer wavelengths. These wavelengths have started to include those of visible light. Remember that the colour of visible light depends on its wavelength, with reds and yellows having the longest wavelengths. So since the poker is emitting long wavelength visible light, it glows orange. Then, if the temperature is increased further to 1000 degrees, the poker would start to glow white. Now this is because the waves being emitted now consist of all the visible wavelengths of light. Remember that this would appear as white light, which is the result of all the possible colours overlapping. For your exam, you won't be expected to recall these exact temperatures and colours, but you will need to be able to explain how an example like this demonstrates emitted wavelengths changing with temperature.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!